students and welcome to my channel. So this is my third video for the topic crystal structure for BSc and MSc solid state physics, and today we will be discussing about why 5-fold and 7-fold symmetry is not possible in a lattice. In my previous video I thoroughly explained how many symmetry operations are possible in a lattice, and we discussed about rotational symmetry in thorough detail. This is a topic which is linked to rotational symmetry, and it says that 5-fold symmetry and 7-fold symmetry is not possible in a lattice. We will discuss why. So first of all, you should be familiar with two important concepts. First being n-fold symmetry. What is a n-fold symmetry? I explained in my previous video, but I will briefly go through these two topics. So n-fold symmetry, by taking example of a square, let us understand that n-fold symmetry is basically, it tells me that how many times should I rotate a particular structure so that it comes back to its original place or its original position. So by considering a square, if I rotate it 4 times with an angle 90 degree, then it will come back to its original position. So it is said to have a 4-fold symmetry. So for any lattice, I can have 1-fold symmetry, 2-fold symmetry, 3-fold symmetry, 4-fold symmetry and 6-fold symmetry. 5 and 7-fold symmetry is not possible, and we will discuss why in this particular video. Second concept that you should be knowing is what is a translation vector. Translation vector is basically distance between two lattice points in any lattice. It is given by T, and the relation of translation symmetry with fundamental lattice vectors is n1a1 plus n2a2 plus n3a3, where a1, a2 and a3 are fundamental lattice vectors in x, y and z direction, and n1, n2 and n3 are any integers. This was thoroughly explained in my first video. If you are not aware of both of these topics, then please go and watch my 2 previous videos and you will understand them clearly. So now, to understand why 5-fold and 7-fold symmetry is not possible in a lattice, let us take this system. Here I have 4 lattice points at A, B, C and D. So I apply a rotational operation at this lattice point and I rotate this with an angle theta, and this point now comes at A prime. So I have just applied a rotational operation and I rotated this particular lattice point with an angle theta, and this now comes at this point A prime. Similarly, I apply a rotational operation at the lattice point D and this becomes D prime. So I join A prime and D prime. So these are my new lattice points. From this point B and C, I join this line A prime, D prime, and this point I label as B prime and this point I label as C prime. Now I know that T is the distance between any two lattice points. So AB, BC, CD are all T, which is the translation vector. So the projection of B, B prime and the C, C prime. So B prime, C prime is also T. So now what I want to know is what is A prime, B prime and what is C prime, D prime. So from trigonometry, cos theta is base upon hypotenuse, and base here is A prime, B prime and C prime, D prime in both of these triangles. So cos theta equals to A prime, B prime divided by A prime, B, which is the hypotenuse, and in this triangle cos theta is equals to C prime, D prime divided by D prime, C. Now A prime, B and D prime, C are nothing but translation vectors, which is the distance between two lattice points. So this is also T. So cos theta is equals to A prime, B prime divided by T, and here in this triangle it is equals to C prime, D prime divided by T. So this is what I want to know. So cos theta is equals to a prime b prime divided by t and c prime d prime divided by t. So I want to know what is a prime b prime. It comes out to be t into cos theta, and c prime d prime is also t into cos theta. So this is t cos theta and this is also t into cos theta. Okay, and distance between two lattice points is t, so b prime c prime is also t. So I wanted to know what is a prime d prime. So this is equals to a prime b prime plus b prime c prime plus c prime d prime. Okay, so this is t cos theta. So this is t cos theta. This is nothing but t, and this is also t cos theta. So a prime d prime is equals to t cos theta plus t cos theta, which is 2t cos theta plus t. And now a prime d prime is nothing but m into t. Why? Because this is also basically distance between two lattice points. So it will be integral multiple of the lattice translation of vector t. So I can say that a prime d prime is nothing but translation vector into some integer. Okay, so putting it in this equation, mt equals to 2t cos theta plus t. So rearranging, 2t cos of theta is equals to mt minus t. So 2t cos theta is equals to t into m minus 1. So t cancels out. Cos theta is equals to m minus 1 divided by 2. Now m I know is an integer. So m minus 1 will also be an integer. I can denote it as some number n. So cos theta is equals to n divided by 2. Okay. So now I know that my n is 2 into cos of theta. Cos theta can have minimum and maximum values from minus 1 to plus 1. So n can have how many values? From minus 2 to plus 2, because n is twice of cos theta. So this is basically a very important relation. This is basically the relation which we wanted to derive, and this relation will tell us that why 5-fold and 7-fold symmetry is not possible in a lattice. So now with this important relation, n is equals to 2 into cos theta, I know that n can have the values from minus 2 to plus 2. So I can construct a table and I can calculate the value of this small n, which is nothing but 2 pi by theta, which is the n of n-fold symmetry, and from these values we can conclude that if 5-fold symmetry or 7-fold symmetry is possible or not. So let's see. So n can have values from minus 2 to 2. So from minus 2 to 2, minus 2, minus 1, 0, 1 and 2. So correspondingly, if n is minus 2, then cos theta is minus 2 by 2. So cos theta is minus 1. So when n is minus 2, cos theta is minus 1. When is cos theta minus 1? When theta is 180 degrees. And when theta is 180 degrees, I can calculate n, which gives me n is equals to 2 pi by 180 degrees, which is 2. Similarly, when n is minus 1, cos theta comes out to be minus 1 by 2. And when is cos theta minus 1 by 2? At an angle 120 degrees. So putting the value of 120, theta is equals to 120 degree in this expression, we get n is equals to 3. Similarly, at n is equals to 0, cos theta is also equals to 0, and it is 0 at theta is equals to 90 degrees. So putting the value of theta here, n is equals to 4. Similarly, with n equals to 1 and n equals to 2, we get the values 6 and 1. So looking at these values of n, you can see that n is equals to 1, that is 1-fold symmetry, 2-fold symmetry, 3-fold symmetry, 4-fold symmetry and 6-fold symmetry are possible, but n is equals to 5 and n equals to 7 is not in this picture, is not in this table. So 5-fold symmetry and 7-fold symmetry is not possible in a lattice. So this was all about this topic, and this is a very important question from your examination point of view. So please subscribe the channel if you haven't done it yet, and if you have any questions, comment down below, and if you want notes of this particular topic, comment down below and I will provide you that. Thank you.